Customer demand for multicolor 3D prints is high, but trying to meet that demand without a strategy can quickly bottleneck a growing print farm. It is tempting to buy the newest 4-tool head or multi-hot-end printer, assuming advanced hardware alone will clear the production queue. This chart compares the print time of a 4-color model. On a single nozzle system, this massive segment is just purge time. On a tool changer, we see a setup overhead segment instead. The overlaid trend line shows how profit margins drop sharply when you mismatch the job to the machine architecture. When you route a complex 5-color job to a single nozzle machine, you pay a time penalty for every automated filament swap. The sheer volume of purge waste and changeover time destroys the profit margin before the print even finishes. The reverse mistake is just as costly.
Tying up a dedicated multi-tool head machine with a simple single-color run inflates your setup costs and leaves highly specialized hardware sitting idle. The objective is to maximize the value the customer actually sees without inflating the cost to produce it. We have to evaluate hardware, material tiers, and design psychology through a strict return on investment lens. Profitability in a scaled farm comes from treating every printer and every material as a strict specialist. This chart is our primary framework for optimization. The x-axis tracks production input, time, waste, and setup. The y-axis tracks perceived customer value, the aesthetics driving a sale. A farm loses money operating in this bottom right corner, exerting high input for low customer value. Single nozzle machines like the A1 or P1S excel at single color throughput. Forcing them to churn out complex multicolor display pieces ties up your most dependable workhorses with endless mechanical color changes. If you have a complex multicolor batch, that is where advanced machines like the U1 tool changer or the H2C multi-hot end belong. Protect their queue availability for jobs that actually require separate mapped colors. Beyond color, you must match the physical geometry of the model to the right machine architecture. Take a tall, narrow structure. On a standard bed slinger, the print moves back and forth with the build plate. As the Z height increases, that motion amplifies the wobble at the top of the print, severely raising the risk of a late-stage failure. To guarantee reliability, tall or skinny models should be routed exclusively to stable Core XY machines, like the Centauri Carbon or the P1S. Assigning a print job requires matching both the color count to the toolhead technology and the physical geometry to the motion system. Once the hardware is matched, strategic material selection is the next major factor in your profit equation. Returning to the quadrant chart, look at this point in the top left quadrant. You can generate massive customer interest without requiring any multicolor machine setup at all. Running a gradient or co-extruded filament on a large model, like a Dragon, creates a dramatic visual transition that justifies a premium price. Yet it prints with the exact same efficiency as a basic single-color job. However, applying that same gradient filament to a small model is a mistake. The color break will likely land awkwardly, obscure the facial features, and ruin the final product. You can also make the inverse error, deploying premium materials on simple, high-volume structural products. If a customer cannot notice the finish difference on a basic shape, paying for premium material simply erodes your profit margin for zero aesthetic gain. Use economy or standard tiers where they fit. Material tiers also dictate machine speeds, and relying on universal speed profiles is an operational risk. Regular PLA prints efficiently at 150 to 250 millimeters per second. But if you push silk or transparent filaments at those standard speeds, you will tear the material and destroy the glossy finish. Standardizing speeds is profitable, but standards must adapt to the physical limits of the material tier. Otherwise, an aesthetic upgrade just becomes a batch of failed prints. In a commercial farm, the strongest return on investment comes from optimizing for emotional connection. When a customer evaluates a cute, articulated creature, they naturally look at the face first. An isolated material change in that focal point dramatically alters how the product is perceived. Upgrading the eye material to a specialty filament, like Deeply Galaxy Black, changes the character of the entire model for very little extra overhead. A glossy or sparkling eye catches the light, giving the design a sense of life and personality that a flat color fails to achieve. This does require a localized multicolor setup, but the input time to swap colors for just a few small layers is negligible compared to the massive boost in desirability. Looking at the quadrant chart again, targeted material upgrades on the face offer higher value than almost any other technique in the shop. Isolated, intentional material upgrades on focal points create far more customer attachment than mindlessly adding colors to the entire body. This flowchart consolidates the farm's specialization strategy into a strict workflow. First, understand the geometry. Second, choose the printer technology. Third, choose the material tier. Fourth, map colors, protecting the eyes. Finally, apply slicing standards for that exact combination. If your operation focuses on high-volume, budget-friendly merchandise, your fleet strategy should heavily prioritize efficiency. Rely on your single-nozzle machines. Use gradient or co-extruded filaments to create visual interest without the burden of toolchain overhead. But if you are competing in the premium, multicolor, articulated market, your priorities shift entirely. Guard the queue times of your multi-tool head and multi-hot end systems. Reserve them strictly for prints where multiple colors are mandatory for character recognition. Do not add extra colors to a model merely because a machine has the physical capability to hold them. A truly profitable print farm protects its margins by matching materials to the exact geometry. It elevates key focal points, like the eyes, and it optimizes the output of the entire fleet rather than a single build plate.